Hi everybody. Sorry I can't be here today, but I figured I would work along through the lesson worksheet to help everybody out and give you something to look at and listen to as opposed to just looking at the answer key. So we're starting off a unit today, law of exponents, which I feel like everyone's pretty okay with. So the first rule, if we have the exact same base, what do we do when we multiply? Well, in this problem, in every problem, we're going to get base of x plus y. Now, I'll also lead with the saying that I left my Apple Pencil at school, so I'm sorry my handwriting looks probably like disgusting. So if we're multiplying, we add. If we're dividing, we subtract. All right, two basic rules from back in the day. All right, jumping to 4. If we're distributing the exponent, we'd have a to the x followed by b to the x. The same thing if it's a fraction. A to the x power over b to the x power. So those rules are all pretty straightforward. 6, power to a power. When we go power to a power, we multiply the two exponents. All right, 7, every single number besides 0 or thing raised to the 0 power is 1. If we have a negative exponent, when you have a negative exponent, you drop it to the denominator and make it a positive exponent. And vice versa. So if we had 1 over b to the negative 2 power, that's the exact same thing as b squared. And when we're working with these, I'm always recommending, move things around so you have a positive exponent. I never work with negative exponents. I start a problem, I move everything around, make everything positive, and I'm good to go. All right. If we have a fractional exponent, right, 1 over q. Q is our index. Right, so that's why if we have b to the 1/2 power, that's the exact same thing as the square root of b. Right? If we have a number in the numerator, right, so if we have a number in the numerator, we can write this one of two ways. Right? You can write this as b to the power of p all under rad q. Or we can flip it around. We have q, the q root of b, all raised to the p power. Now it does not matter which way you do it. Either way will give you the exact same answer. Right, so depending on what we're doing, it might benefit you to do it one way or the other. Now, an important rule is to talk about. This comes up, I see this every year. X minus 2 squared. This will never ever equal x squared plus 4. Right. We cannot distribute the exponent. What we have to do in this situation is we must FOIL. X squared minus 4x plus 4. Right, so we cannot distribute an exponent over addition or subtraction, but you can give an exponent out in all the situations when you just have things being multiplied, like 4. All right, let's look at some practice examples together. All right, so we have options here. I'm going to look at both ways to do this. So the first part versus the second part, they both have a negative exponent. So what I'm looking at in the first part is you could give out the negative exponent. B to the negative 4 power over a to the negative 2 power. The other option is, with the second fraction here, is you could rewrite this by flipping the inside fraction and making our exponent now positive. So that's perfectly fine. What I did by just giving out the exponent in the first situation, that's fine too. So this would give us now b to the 3rd over a to the 6th. I don't want to work with any negative exponents. So I'm going to rewrite my left fraction. A squared over b to the 4th times b to the 3rd over a to the 6th. All right, now here I'm going to do some canceling. All right, so you could cancel vertical, you could cancel diagonal. Can't cancel horizontal. I'm going to cancel out both a's and leave myself with a to the 4th down here. I'm going to cancel out all 3 b's and leave myself with just b to the 1st down there. By doing that, my final answer is 1 over b a to the 4th. That's what I got for that one. All right, problem 2. Issue with problem 2 is this. You cannot distribute the exponent. A lot of people say that this is going to become a squared plus b squared. No way. All right, so what do we got to do? We got to work inside. 1 over a squared plus 1 over b squared, all raised to negative 1 power. All right, so we still can't give out our exponent. So what do we got to do? We got to combine the inside. We got to get a common denominator. So I got to give this fraction a b squared over b squared. I got to give this fraction an a squared over a squared. By doing that, with my common denominator, I have b squared over b squared a squared plus a squared over b squared a squared. Right? Which gives me, well again, this is all still in that negative 1 exponent, which gives me b squared plus a squared over b squared a squared, all raised to the negative 1 power. So what does that negative 1 power do with this problem? Flips it. Right? So all we can do is flip the internal fraction, giving us b squared a squared over b squared plus a squared. I wrote a up there. That should be a 2. And that is our final answer. All right, jump into problem 3. All right, what can we do with this? Well, we have options. We always have options. You can separate this into 2 fractions. You could bring up and have a, looking at both options. You can go with the way of, I'm going to make this a to the 5th over x to the negative 3rd plus x to the negative 2 over x to the negative 3rd. That works. Or you could go with x to the 3rd times x to the 5th plus x to the negative 2. Either way is going to get us the exact same answer. All right, so with the bottom one, we're going to move up our x to the negative 3rds so we could try and get a more simplified answer in this situation. All right. Over here, in this one, we're going to distribute. Well, either way we do it, our answer is going to be x to the 8th plus x. All right, because over here, we're going to have x to the 5th plus 3, while over here, we're going to have negative 2 plus 3 to give us that positive. So whichever way you do it, perfectly fine, we get the exact same answer. Problem 4. Again, I'm not working with negative exponents. I'm moving things around. X to the 5th, I move up the x to the 3rd, I drop down the x squared. I do some canceling. That's gone, that's gone. My final answer is now x to the 6. I'm not gonna lie, I'm pretty impressed with my handwriting. I didn't know what to expect when I left my Apple Pencil at home. At school, I actually went a little insane this morning, but I'm doing okay, and I'm making this work. All right, now we got rads. So one thing I know right away in this problem is that the only way to make this work is to have the exact same bases. So I see 5, 25, 125. I know they all come from a base of 5. I also know that the big rad is the exact same thing as a half exponent. So if I do a little changing here, I'm going to have 5 squared to the 3rd times 5 to the n all over 5 to the 3rd raised to 2 minus n all raised to the 1/2 power. Alright, so I can do some combining here. This times this gives me 5 to the 6. This times this gives me 5 to the 6 minus 3n. Alright, so in my denominator, I can't do anything. I got 5 to the 6 minus 3n. My numerator, multiplication with the same base we can add. So I can get 5 to the 6 plus n. Again, this is all raised to the half power. All right, continuing on this idea, on the inside, I have bases of 5. I have division. With division, that means we subtract 6 plus n minus, in parentheses, 6 minus 3n, which is going to give me 5 to the 4n. Again, raised to the half, raised to the half. So now that I've broken down to one thing raised to the half power, I can distribute my exponent to give me 5 to the 2n. So the key thing with a problem like this is making sure that we get everything in the exact same base. By having the same base, we can use our multiplication rule, our division rule, our power to a power rule. All those rules would come into play. 6. 1/4 power is the same thing as the 4th root of 16. What number times itself, times itself, times itself gives us 16? 2. All right. We have a negative and a fractional exponent. All right, so first thing I'm doing, 1 over 8 to the 2/3 power. Now, as I talked about earlier, you have options here. You could first take the 3rd root of 8, or you could square 8. It doesn't matter which way you do it, we're going to get the exact same answer. I'm a fan of doing it in a way that's just going to benefit me. So know if I can keep the numbers small, that's what I'm going to go with. So this would give me 1 over 2 squared, which is 1 over 4. Now if we did the other way, 1 over, we'd have 8 squared, 3rd root of that, 1 over the 3rd root of 64, which is the exact same answer. Doesn't matter which way we do it, it all works out the same. Last problem. The key thing here, I'm going to start off, I'm going to drop the negative down, and I'm going to make my rad into a power. So what I have here is 27b squared all over a raised to the 1/6 power raised to the 4th power. So with my power to a power rule, I'm going to combine these, which is going to give me 27b squared over a, all raised to the 2/3. Now I'm going to give out my exponent. So that's going to give me in this situation 27 to the 2/3, b to the 4/3, and a to the 2/3. So 27, the 3rd root of 27 is 3, squared is 9. I got 9 to b to the 4/3 over a to the 2/3. Alright, there we have it. I hope this video was helpful. If you have any questions, please feel free to reach out to me. Stop by for help. Next time I see you, we'll continue on. I'll take all questions we have on this, but we'll keep moving. Good luck on the exam. If you have questions on the exam, tell the sub to email me. I'll answer them as best as I can.